Hi, I'm Mark, and this is Deb. We're with Fauske Associates. Our sample has arrived at the lab, and we're ready to test.
Hold on a minute, Mark. Before we get started, make sure we have safety glasses on anytime we're in the lab.
Thanks, Deb. Let's do this. The customer that sends the material to us lets us know whether they want it tested as received or per the ASTM recommended standard of less than 75 microns.
Remember, if you're not testing for the recommended 75 microns, you may be producing explosion sensitivity data that is not conservative enough to design your protection.
So let's take a look at the samples that have come in. Some the wrong way, others the right way. When we receive the material, we want to have it be light, fluffy material, things that are going to stay lofted in the air. Some examples that show up at our lab that think we can test is something like this. That's not going to work. We've had some samples that arrive just loosely in a box, and that's not going to help anyone, especially the paperwork that's inside. Ideally, you want your sample to come in a container that is unbreakable and has a screw top lid with little chance for moisture to get into the sample.
Here's an example of proper packaging for a sample. Plastic bottle, secure screw tight lid, clearly labeled with the name of the company, the contact, the sample name, and any special instructions that the client might have.
Now we can make our way into the prep lab and get our sample ready for testing per the instructions of the customer.
We can prep your material in a number of different ways, one of which is sieving through this 200 mesh screen to achieve your minus 75 micron. We can grind it. We also check the moisture content of the material. ASTM recommends testing at less than 5%.
Now that our sample is prepped, we can go into the testing lab and see if it explodes. The first step is to determine if the material is explosible, which is also known as a go-no-go test. Our initial testing starts with the modified Hartmann tube. This will expose the material to a 10 joule constant arc ignition. So if the material is explosible here, it most likely will explode in the 20-liter chamber. A go result allows us to immediately move the material to the section of the lab that can tell us under what conditions the material will react. The other portion of the screening package is a combustibility screening test. This will determine if the material will support a flame while in a pile. If your facility has hot atmospheres from ovens or heavy machinery, this is a good test to consider. Keep in mind, even with the no-go result of your explosibility test, you may still have combustion concerns. Now that we have prepped and screened our sample for combustibility and explosibility issues, we're ready to move on to the next phase of the process. The Fauske on-site service team is available to come to your facility or just help you with the next phase of the process and decide on what testing is now needed. Fauske Associates is here for you to serve your process safety needs. Let us know how we can be a resource. Fauske Associates, world leader in nuclear and chemical process safety.